This video is sponsored by Sobrancy Web Hosting. For more information about their limited time offers and how you can get 90% off your first month, stick around to the end of the video. Hey guys, my name is Ethan, this is Carberra. Welcome to what is essentially going to be a crash course in SQL. I did already have one take at this and I realised that this video is probably going to be quite long. So I'm just going to say it's a crash course, hopefully it'll be done in about an hour. Probably less, probably about 45 minutes or so. But yeah, this is just kind of a crash course of the basics of SQL, the very basics. We're not going to get into anything too complicated. We're going to be using SQLite 3 as our model because it's the simplest model out there. It's probably the easiest for me to do a tutorial on. And ultimately it's very, very similar to MySQL as it's basically just a different version of SQL. Of course, there are other database models out there, which brings us to the first thing I want to talk about, which is database models. There are many different types of them out there. So there is MySQL, there is PostgreSQL, there is SQL Server. Not all of the syntax in this video is going to work for all of those things. I will point out the differences in a syntax between models where I know of them. There are inevitably going to be one or two that I miss. But database models also have different data types, or more specifically, SQLite has different data types to other SQL models. They are simplified into 5 groups, and this table here will kind of show what it is. So in this resulting affinity table are our SQLite variables, or data types, sorry. So you have an integer, a text, a blob, a real, and a numeric. And in this example type names, we have all the different data types that you can get in other database models. So you can get different types in an integer, the same. You can get tiny int, small int, medium int, big int, unsigned big int, and all that stuff. And then in text you get like characters, varchars, or varchars, maybe, I don't know. And you get the standard text. And then the numeric category is quite interesting because you get standard numeric, not really sure what that's supposed to mean. You get a decimal, don't know how that's any different from a real, but whatever. And then you get Boolean, dates, and date times in numeric. SQLite is fairly unique in that if something is a particular data type, it will just convert it automatically, but it's a lot faster if you actually get it right. Which is, yeah, you probably should get it right. You probably should get into a good routine, and once you've nailed these, you can then move on to the more specific ones for faster and more scalable database models, such as MySQL, such as PostgreSQL. I do want to talk about blob real quick. We're not going to be using it in the video today. We're not going to be using real either. This is basically just a float, whereas this is an integer. So this has a decimal. This doesn't. But there's not too many instances where you need to use this, but I'll talk about that later. The blob stands for binary large object, and it's essentially generally a file. So an image or a music file or something like that would be stored as a blob. Again, we're not going to be using these two in today's video, but I just thought I'd briefly touch on that. For those of you that have never really seen SQL or worked with databases before, you'll be glad to know that SQL is a very specialized language. It stands for server query language. It's literally designed to work with databases. And that also means that its syntax is very understandable and very English, really, and thus pretty damn easy. However, there are some more complicated aspects of databases, like stuff in relational databases, like foreign keys, that are more advanced. I am going to be talking about foreign keys briefly in this because they are, as much as they are, you could argue, an intermediate concept, they are very important to how databases actually work. So yes, we are going to be talking about keys and stuff. So we're going to go back into our file, our new file. We don't have anything here, and we're going to create a new file, and we're going to save it, not in the plan. Yeah, I made a plan for this just to make sure I was getting everything right. We're going to call it script.sql. I don't have a proper name for it. You can call it whatever you want. We're going to be, in this example, we're going to be creating like a customers, products, orders kind of thing, because I feel as though that's just the easiest way to explain stuff. So we're going to start by creating a few tables. So we're going to create a table called customers, and we're going to have brackets, and that needs to have a semicolon at the end of it. And then we're going to have a customer ID. It's going to be an integer, spelt correctly, of course. That's going to be a primary key, and it's going to auto increment. Now there's a lot to unpack in this line. So customer ID is the name of the column. You can have it in backticks, I believe. I don't know which is preferred, honestly. I'm pretty sure it's optional. There's probably some database model out there where they're required, so I'm just letting you know. I personally don't use them, but you can use them if you want. It doesn't really matter. The integer is obviously just a data type. The primary key states that this is the main column of the table, and it also applies a unique constraint to it. So you can't have two of the same customer ID in the same table. So that just basically just sets all of that up and says that the customer ID is almost like the root or the main part of this table. And then auto increment essentially just allows the default handling in the back to do a lot of work to allow us to enumerate IDs. So in some instances you don't want to enumerate IDs. In this case we just kind of are, because it's not really too important. There was of course that incident with Moonpig a few years ago where they enumerated all the customer IDs, and it was a massive security flaw. So in some cases you wouldn't want to do it like the way that YouTube does video IDs, it just randomizes them. In this example, auto increment would be perfectly fine, and because it's an integer type, it will start from 1, it will just continue climbing up the list. And then we're going to have customer name to be a text, and then we're going to have a customer phone as well. There will also be a text. Note that there is no comma at the end of this line because it's the last one. If you get in syntax errors, more likely than not, it's either you've added a comma where it shouldn't be, or you've removed a comma, or you've forgotten to put a comma where one should be. That's very common. A quick note about the data type. So in here, instead of integer on other database models, you can have big int. And you can actually, as this says, you can actually use these in SQLite databases. However, they will get converted into other data types. I think it's just more efficient to use the standard SQLite ones in SQLite databases. With text, you can use, say, example, varchar 15. The difference between char and varchar, or car and varchar, and probably is actually, now I think about it, is car 15 is expecting exactly 15 characters. Varchar is expecting up to 15 characters. So that's a very important distinction. I actually don't know what ncar is. I didn't know it existed until I looked at this table. Native character, that appears to be something. I don't know. I don't know what all these do, but whatever. We're just going to use SQLite data types for now. But once you've kind of got the hang or the handle of databases and SQL and how it all works, then you can start looking into different database models. I'd recommend PostgreSQL. Apparently it is the fastest and it's most fully featured, and there are Python packages for that as well if you do want to use Python. SQL is built in, so it's easy to explain with. But you can look up all this stuff, and you can make determinations for yourself about how to optimize what I'm about to teach you. But this is, if you're watching this, I'm presuming this is your first time with SQL, so that's why I'm just sticking with this. So we need to create another table called products. That's not my time. I did. Cool. And oopsie daisy. And then we're going to have, it's ultimately going to be very similar actually. So product ID of integer again, primary key again, and auto increment again. And then we're going to have a product name, which is going to be a text, and we're going to have a product base price. Base price, which is actually going to be an integer. I just realized in the plan I put it as a text, and I don't know why. Yeah, that was a mistake on my part, but at least I've noticed it. So yeah, as I put that in the text, it did an error, so I didn't actually catch it because it automatically converted it to an integer. However, you do realistically want to put it as an integer. You could put it as a real as well. So say if you wanted to do like £215.50, you can have it as a real and it would input like this. Or more preferably, you can have it as an integer and store it as 21,550 pence or cents or whatever your form of currency is. This is faster than a real in basically every single context. You shouldn't really use reals unless they're absolutely necessary, because integers are just quicker. And then we're going to create another table for our orders, and this is where the magic is going to happen. We're going to introduce a few other things. So order ID, again, very similar to the other two. It's going to be an integer, it's going to be a primary, and it's not going to be a product ID, it's going to be a primary key, and it's also going to auto increment. We're going to have a customer ID, which is going to be an integer. We're going to have a product ID, which is going to be an integer, and I'll get back to those in a second. We're going to have a discount, which is also an integer. And then we're going to have our order date time, which you could put as a number of different data types. I've always put it as a text in the past because that's worked. However, according to this table, we should, because date and date time here, we should actually use numeric instead. So you could put date time like that in other models, and this model it would be converted out into a numeric. And that was going to default to the current timestamp. So there is a little bit to unpack in this line. So of course the numeric I've already explained. The default keyword sets the default value if we haven't explicitly specified it. It'll make more sense when we actually go to generate some orders. But this current timestamp is, at least in MySQL and SQLite, a variable that you can use to display the current timestamp. There are a number of different ways you can do that. I think you can have like current time, current date, and all sorts. I believe you also have a date time like function. If you do like date time and then now, I think that'll do the same thing. I don't know if that works in the default though. I do know you can use this to do like offsets, so the now plus 10 seconds or something. You would do using that, but we're not going to bother with that. We're just going to use the variable that's provided. So now with these orders, we have the order ID, but we have this customer and product ID as well. And you may be thinking, well, why are these here? We've already defined these here. Well, we are actually going to set those as foreign keys. So you do a foreign key customer ID references. Oh god, if I could actually spell customers customer ID on delete cascade. Now there is a lot to unpack with this line. So we are defining a new foreign key. In some database models, I think you have to specify constraint and then give it a name. I don't know which ones. I've never seen anyone need to do it. I just kind of do it like this. Maybe SQL 7 needs to do it or something. I don't know. But we are setting our customer ID here as a foreign key. So we are essentially saying that we're going to be connecting it to a column in another table. In this case, our references is saying what table it's going to be, so customers, and exactly what column we want it to connect to, so customer ID. So customers, customer ID, and orders customer ID are now connected into one. Well, they are separate, but they are connected. One thing that allows us to do is it allows us more ease of operations, so we can do more operations with this. It also prevents an ID going into orders customer ID that isn't already in customers customer ID. So you can't have, say if there was only 5 customers, so 1 through 5, you couldn't have a customer ID of 96 going in order, because that's not a thing in customers. It doesn't work. It will throw an error. So it's essentially like a little bit of extra validation. And it also allows us to use this on-delete cascade. Now, what's happening here is when we delete a customer ID from the customers table, and we will be doing this right at the end of the video, it will actually delete all the orders, but the customer ID is the one that was deleted. So say that we delete customer ID number 5, for example. It will go through the orders table and delete every record where the customer ID is also 5. So that just allows, it essentially just means that we don't have to create multiple SQL statements to delete everything from everywhere and potentially get it wrong. It just does it for us, and it's reliable and it works. You wouldn't necessarily need to do this in all situations, and foreign keys by no means have to have on-delete cascade. I'm just doing it in this so I can actually just show it off, because it is a fairly important part. But it is an optional thing. So we need a second one. We need to get rid of this chain comma as well before we forget. And we need to essentially change customer in here to product. And then we also need to change that to lowercase p. Thanks, Sublime, do appreciate it. So our 3 tables should look like this. So you should have customers with these 3, products with these 3, and orders with these 5, and then the foreign keys are set up correctly. There are a few other table-based operations that I want to show off in the script. There is the drop table that we're not going to be keeping. We're not going to be dropping any tables, but you can drop a table, say orders, for example, and I'll just delete an entire table. We don't need any more. Just delete the whole thing. That's quite a dangerous one to use, though. And we're not going to be keeping anything, but I just wanted to mention that because it's quite an important one. Then you have alter table, which you are going to be keeping. And then, so say we can alter customers, we can add a column, or we can rename a column as well. We can do all sorts of other things. I think we could delete a column too doing this, I think. I don't know if it's delete or remove, though. You have to look up. We're going to add a column to customers, and we're actually going to add the customer email column because we realized, oh no, we forgot in the base setup, we realized that we forgot to do it. Obviously, I can just add it here because we haven't built a database yet. But if you do need to alter the table after the database goes live, then you can do something like this. For complex databases, it's going to be a lot more complicated than that. But again, we're just focusing on the basics. So now we need to insert some things into our database. And we're going to insert into customers. And we're going to insert some values. So this statement here, as it stands, is what you would use if you're inserting something into every single column. So in the customers, if you're inserting something into customer ID, name, phone, and email. However, we're not doing that because customer ID is automatically worked out for us, so we don't need to do anything there. So we need to actually specify which columns that we want to add to or insert a record in. So we want to do customer name, customer phone, and customer email. And we can come down to a new line. It doesn't matter. Again, semicolons are how SQL works out that something's ended, so new lines are perfectly fine. I'm just going to copy paste some pre-built data. Where my mouse gone? There we go. I lost it last time I tried to do this as well. Yeah, this is just some sample data. One thing I should mention is that these phone numbers are Ofcom numbers, so you can't dox anyone. I was particularly potent about that. But we have Anna, Sarah, Rod, Gregory, and Z all in the database, and they're all our customers, so there'll be 1, 2, 3, 4, 5 respectively. In a production database, you would have a lot more than 5, but in a sample database or a tutorial database, it doesn't really matter. And then we do the same thing again, so insert printed products this time. And we only need to insert product name and product base price. Values, and then I'm going to do some more copy pasting. I've set up a little bit of a white goods store apparently here. I just felt it was the easiest. I originally wanted to do fruits, but then the prices seemed a bit low, so I just wanted to make sure that everything was clear. So you can see this is what I was talking about before. So our fridge freezer is 215,000 pence or 215 pounds. So again, it's faster to store them as an integer than it is as a real or a numeric or anything like that. So that's pretty much all we need to do in the script. So your script should look something like this, or hopefully exactly like this. If you're getting any syntax errors, make sure that you look at these commas and make sure that we're all okay. Make sure you look at these semicolons and make sure you have them after every statement. And make sure, I don't know if indentation matters, I'm pretty sure it doesn't. But just make sure that all the punctuation is correct, because SQL errors are not that great. And yeah, so a few more things I want to talk about before we go into our Python program. There are a few other things that you can do to not really maintain integrity, but kind of avoid errors. So in the create table, you can create table if not exists. So if you're going to be running this script multiple times, you can do create table if not exists. If the table already exists, it just won't create a new one. If you don't have this there and you run this again, it will actually error. So this just kind of avoids the error and it doesn't corrupt anything. So that's a good one to remember. And then insert into has a similar thing. So you have insert or ignore into, which does, well, pretty much the same thing. It inserts something if it can. If there is some sort of unique constraint failure, then it will just bypass it. Just like, nope, not doing that. If you want a bit more control, you can come to the end, specifically the end, and do on conflict So just say if there is a unique constraint, then what do we want to do here? You can do nothing. That will work. It's an alternative to insert or ignore into. I kind of prefer the insert or ignore into because it gives it provides that syntax at the start rather than at the end. However, you can do this, or you could do on conflict update, and then I can't remember what the exact syntax here because I've never really done it. But you can potentially do something like customer name equals something or something like that. I don't know. Or you can do like if you had maybe an experience system, you could do XP equals EXP plus 1 or something. So you could say, oh, try and insert this new user into our database, but if they are already there, then we need to update the number of messages they've sent or something like that. And something you could do with that. I'm not going to keep any of that because we're only going to run this script once. So again, make sure it looks like that. Make sure everything works. Make sure everything's fine. Well, I guess it can't make sure everything works at this stage because I haven't built the program to actually run it yet. We're going to do that right now. So we're going to create a new file. We're going to call it program.py. I can't think of a better name. Maybe I would have thought of a better name by the time I put this in the repo. I really don't know. We're going to do some imports. So we're going to do import datetime as DT. Thanks, autocorrect. Really appreciate it. We're going to import random. And we're going to import SQLite3. These first two I'm just using for random generation of orders because we need to populate our database somehow. I'm actually going to close this one down while I'm here. And then SQLite3 is the library that we're going to use to connect to our database. SQLite3 is actually built in to into Python. You don't need to pip install anything. But there are others available. So for example, if you're using PostgreSQL, you could do import async pg, I believe is the best one out there for that. And you would have to do a pip install of that because it's a third-party library. But SQLite3, because it's simple and basic and good for prototyping, and Python is also good for that, then it fits together. It fits very snug, like a very snug bug in a very snug rug. But anyway, weirdnesses aside, SQL.3 or .connect. Let's specify a file path to database.db3. Again, a little bit onto unpacking this statement. So this CXN is our connection object that we're going to be using to run commands off of. You can call this whatever you want. I think con is a fairly common naming convention, potentially, I'm not sure. I like to just call it CXN because I like the 3-letter variable and I like the 4. Is this standard? I don't know, but I like it. You can call it whatever you want. It doesn't matter. And then we're just connecting in, and we're connecting to our file path here. So this // basically says this dot is the current directory, and then we're creating a file, database.db3. You don't need this // I just prefer it. I might leave it out for the purposes of this tutorial, just so people don't get confused. But if a database doesn't already exist, this method will create one for you. So you don't need to have the actual database in existence before you run this, but you do need to have the directory it's going to be in. So say if you had it in a data directory, if that data directory didn't exist, it would error. So you need to create all the directories, or you need to create a directory it's going to exist in, but you don't need to create a database. That's a very important distinction. I'm going to save that. And in order to enable some of our foreign key stuff, so on cascade delete or on delete cascade, in order for that to work, we need to actually enable some foreign key functionality that for some reason is disabled. I think this is an SQLite3 thing. I don't know the other models. I'm presuming PostgreSQL has it enabled by default. But you could do cxn.execute pragma foreign keys equals on, and then a semicolon. You can try without this line if you want, if you're using a different model from SQLite3. If you are noticing that things aren't working quite right with regards to relations and stuff, then execute this command and things should fix themselves. But for SQLite3, you are going to need it for the stuff we're doing here. There's no harm in running it anyway, really. So if you're confused about what this does and you're like, I don't know if I need this or not, then just execute it anyway. It's not going to do any harm. And also, you need to put that there, not in a script. It needs to be done every single time we make a connection database. Otherwise, it will only be in effect once, and it won't work. I found that out while I was playing this series, because I was like, what the heck? But yeah, anyway, I'm playing the video, sorry. So the first thing we're going to do is we're going to build the database. I'm doing these in functions to compartmentalize stuff. You don't have to do that. I'm just doing it to make it easier. So we're going to with open script.sql. Again, you could specify the directory in here if you want. Doesn't matter, but it needs to be in actually, does it need to be an SQL file? It probably doesn't actually, but for when you're actually writing it, you want kind of the correct thing. In read mode, and we're going to set the encoding equals UTF-8. If you're on Linux, you don't need this encoding. If you're on Mac, you may do. I legitimately don't know. If you're on Windows, you probably don't either, but it doesn't specify UTF-8 encoding by default, and I always just do it just to be safe. I think it does it in ASCII otherwise, and ASCII doesn't have a lot of characters to it, so you could end up with an error. So I just always do it. And you could do connection.execute script and an f.read. So we're reading the contents of the file as a script, and then we are executing that SQL script. So that will execute all of this. It will create our tables. It will alter our table. It will insert everything into it. And then finally, once we've done that, we need to do cxn.commit. So a commit in SQL talk, or any database talk really, is the save. Because databases store changes initially in a journal, you need to actually commit the changes to save them properly. This is done in case something goes wrong, and you also have the rollback, which will delete the changes in the journal, and it will revert the database to the state it was in when you last committed, and nothing will be lost, nothing will be corrupted. So it's good in kind of error handling situations. In this case, we're just going to commit. We want to say, yes, we're absolutely committing to saving these changes. And then we're going to make an order as well while we're here before we actually go and run it. We're going to cxn.execute or connection.execute. We're going to insert into, again, you have the insert or ignore into should you wish. Orders customer ID. Again, we're not inserting the order ID because the auto increment handles that for us. Product ID and a discount. We're just going to throw that in, and then we give it the values, and we're going to specify this as a prepared statement, is what it's called. So we're going to use question marks. Some models do it differently. I know PostgreSQL uses $1, $2, which is arguably a better syntax, to be honest. I don't know if SQLite supports that or not, or which database models support that, to be honest. I know for a fact it supports the question mark, so I'm just going to do it, but you can do your own experimenting with whatever database model you want. And I'm actually going to make this one line to make it less confusing. And then we also need to pass in a second argument to this function. So this is our SQL, so this is the first argument. The second argument is our values. So in this case, we're just going to put 1, 1, 0. So this is inputting customer number 1, so Anna, product number 1, so fridge freezer, and no discount because it's just easier. As you can see, 3 question marks, 3 values. If you had 1 question mark, say like, oopsie daisies, if I can actually hit the right buttons, there we go, like that, you would need to put it like this. So you would still have to have the tuple, and yes, you would have to have this comma. In the case of an integer, it probably wouldn't matter. Maybe. I don't know, actually. But in Python, tuples are kind of more whims than actual data types. So something like this, it would just take the integer. It would be as if the brackets weren't there. So you do need to provide the trailing comma to say this is a tuple, treat it as a tuple. But again, we have 3 values, so we don't need to worry about that. That's just a quote of Python, nothing you can really do about it. And then we need to do another cxn.commit. Now we're going to come down here and actually run our script. So we're going to use the if name equals main thing. What this does is essentially only runs it if this is explicitly the file you ran. So if you imported this into a different Python file, it would not run any code inside this if statement because it would return false. But because it's just if you're just doing like simple Python scripts like this is a good practice to get into. So we're going to build our database, and we're going to make our order. We're going to run it and hope we don't get any errors. We didn't. Hey. And then this is the correct database, isn't it? Yeah. So we're going to open this. As you can see, our tables are here. I'll talk about this SQLite sequence in a bit. See, our customers are here. So we have Anna, Sarah, Rod, Gregory, and Z. We have all of them. We have our one order in there, and as you can see, the current time was actually imported. So I'm recording this quite late in the evening. I wasn't originally going to do this about 4 hours ago, but things didn't happen that way. But as you can see, the time is pretty much, so we have 14th of November and 20:46:25. This is pretty much about right. This is the time to the second that things are imported. SQLite, that current timestamp doesn't have microseconds, although sometimes you will have microseconds. They're perfectly fine. You don't need to worry about those. If there is a T in between the date and the time, also don't worry about that. That's perfectly fine. That's actually the more standard syntax. The having the space is the less used one, but it's the one that SQLite uses apparently. So fair enough. We have our products as well, so you have the fridge freezer for the prices, and then you can see the IDs for each one are actually or incremented, so 135, 135, and this is what this SQLite sequence table is for. This just is where it keeps track of it. It just keeps track of it within itself on disk to save performance. With that out of the way and with that all settled, we can actually now go and do some other stuff. So the first thing we're going to do is we're going to generate more orders so we can actually, so I can show off the actual selects. So we're going to come down here and do generate orders. If you're wondering why I'm doing 2 spaces in between functions, by the way, it's because of PEP 8. That is a PEP 8 standard. This whole file is following PEP 8. I'm doing it right. I'm doing it good. It annoys me when tutorials don't use PEP 8 now. Because you should use it, but whatever. So we can do begin transaction here, and what this will do is it will prepare the database to accept a large amount of inputs. So this essentially just, if you're bulk inserting, so if you're inserting 1,000, 1,000,000, 1,000,000,000 entries at the same time, then you want to do it with a transaction, because this will save a lot of time. It will save a lot of time. We're only going to insert 50, so it's not going to be much of a time difference, but it's a good thing to know. So for I in range 50, we're going to do a cxn.execute. Now we're going to do insert into orders. And we're going to insert customer ID. Once again, the order ID we don't need to do because it's handled for us. And then we also actually need to insert something into order date time. I was expecting the order complete to come up there and it threw me off. Values, because there are 4 columns we're inserting into now, we need 4 question marks. I'm actually going to move these on different lines because this is quite a big statement we're going to do. Make sure we have the comma, and then we're going to have these brackets, move everything into the right place. And then this is where our random comes in, so random.randint 1 through 5. Of course, we have 5 customers, so we just select a random one between 1 and 5. Same thing for the product. For the actual discount, we're just going to do random choice. I'm not going to talk about what I'm doing too much because this isn't really important. This is just generation. You can copy this character for character should you wish to. This tutorial does not really concern the syntax here, and I'm actually just going to copy paste the last one. So this essentially says, well, at first, the random choice is like, oh, should I have a discount or not? If it is a discount, it just creates a discount randomly. And this line here generates a random date time object between midnight, 1st of January 2018, and 23:59:59 on the 31st of December 2019. So it's a good little date range to have. Trailing comma for Pepe. Ooh. Yeah, in Python you do want them in JSON, and in SQL you don't. It's confusing, but whatever. So we're just going to do our cxm.commit again, and then we're going to come down here. That's the wrong file. We're going to come down here. We're going to comment these 2 out because we don't want to build our database and we don't want to make another order, and generate orders, and then we're going to do that. Oh, there's an error. What have I done? That's not good. Choice takes 2 position arguments, but 3 were given. Yes. Takes 2, 3 were given. How did you figure that? Oh, yeah, I see. We need another set of brackets there. Yeah. Whoops. So if we build that again, we should. There we go. It actually works. So if we go back into our orders, we'll see that we have a load of orders now. We have a huge wad of no discounts around here. And see we now have 51 to add to our one from before. We have a range of IDs here, a range of discounts, not many, interestingly. And we have a good smattering of dates by the looks of things. And we have just our random one in 2020 there, but that doesn't really matter. So we don't need that anymore, so we're going to comment that out. So what we're going to do is we're going to now create our first select statement. We're 36 minutes in, my goodness, this very much is a crash course. So we're going to talk about selects now. So this first one is just a simple select. Display discounted orders. Cursor equals cxn dot execute select everything from orders where discount is greater than 0. So again, a few things to unpack here. This asterisk is just everything. This is a universal standard across most programming languages. SQL is no exception to that. So this will just return every column. We can specify columns, so we can do like customer name and customer phone specifically if we wanted to, but we don't. We just want everything. And then we're getting it from the orders table. And then we're essentially doing an if statement here. So if discount is greater than 0, then include it in the set is more or less what the where is. And then to actually print the rows, we need for row incur.fetch all, and then print row. I'm going to copy paste that for future use. But this will just print all the rows that we select. So if we go down here, display discount orders, build, and you can see we have all these things here. So all of these have our discounts here. You see like 2, 4, 5, 8, 12. So it has explicitly handpicked all the ones, all the orders that were discounted. So that's pretty cool. Get rid of that using escape. And then we can do display fridge orders. So this one is going to be a little more complex. And we're going to use nested select statements for this one. So again, the cursor, I shouldn't really explain what the cur is a cursor. So every execution needs a cursor. You can define a cursor up here, but if you're doing asynchronous or multi-threaded stuff, you will want to create a new cursor every time just to make sure things don't get messed up. Although it's generally not going to be too much of an issue, unless you're doing it really big scale, but it's fine. I just prefer doing it this way anyway. So cxn.execute once again, and then select, we're going to do this on new line because it's a bit longer. Select all from orders, so the same start, where product ID equals, and this is where things are going to change. So we do in brackets here, and we do another select statement, because this is a thing you can do. Select product ID from products where product name equals, and then we could just do single quotes here. Fridge freezer. So what this will do is this statement will be run first. So it will get the product ID of the fridge freezer, which, oh my goodness, in this case is 1, and then we're going to select all orders from. We're going to select everything from the orders table where the product ID equals 1. And then we're going to use our thing again, and we're going to build. And as you can see, that didn't work because I didn't update this. Display fridge orders. There we go. So if we build that now, so you've got 1. We just have all 1s down here, and quite a lot of fridges going for discounts. We're kind of outselling ourselves here at Carberra White Goods, but that's why you run these things. You run these things to find these things out. Now I'm interested in I've decided I'm just going to role play as the manager of this company now. I'm interested to find the 10 most recent customers, or the customers that had the 10 most recent purchases, I guess. So display 10 most recent customers. This is really kind of display the customer information for the 10 most recent purposes, but that is a very long function name that I don't want to write out, so we're just calling it that. This will do pretty much exactly that. It will display the customer information for the 10 most recent orders. So this is going to use a lot of different things. There's going to be a lot to unpack with this one. This one's very complicated. If you don't understand it, then it's fine. Come back to it later once you kind of know a bit more, but some things will be a bit more obvious than others. So we're going to have the same start, cur equals cxn.execute. Then we're going to have select, and I'm just going to write this, and then I'm going to explain everything. So c.star from customers as C, join orders as O, on O.customer ID equals C.customer ID, and then we're going to have a space so we can use a multi-line string. This is a thing you can do. I learned this very recently. So long as it's in a bracket, so long as it's in a set of brackets, if you have like multi-line strings like this and you don't input the plus, although you probably can, it will just treat it as one string. It's great. It's really cool. But yeah, anyway, order by O.order date time descending limit 10. So yeah, I did say this is a particularly complex one. What we're doing here is the first thing we're doing is we are joining our orders table. We're calling it O. We're giving it an alias to shorten the query down. So we're joining that table and we're joining it on customer ID. We're joining it on the two customer ID columns. I don't think things need to be foreign keys or columns. Sorry, I don't think they need to be foreign keys for this to work. But I think it's preferred. It might be more efficient. I don't know. Maybe it depends on the database model when it comes to that. But essentially, it will just kind of it will combine these two tables into one, but it will use this as a common factor. So you want to specify the common factor. If you don't have this, it will match everything to everything, which you don't really want to do. So you want to match a common factor, and then you'll have this table that has the customer ID, and then you'll have like order information on the end of that. So it's kind of difficult to explain joins, and I don't really want to go into huge detail because it's still the basics. And then we're only selecting everything from the customers table, so we're not printing absolutely everything. I might print absolutely everything just to kind of show what it looks like. Yeah, this second line should make a lot more sense. You shouldn't have any issues with this. So order by the order date time column in the orders table, and we're ordering in descending. So because it's time, we're doing the most recent first. So we're ordering everything. We start with the most recent order first, and we go down, sorting them until the last one is the least recent or the furthest away, or the one that was made the longest time ago. Let's say that. And then this limit 10 limits the number of returned entries to 10. So we can have this to 15, it will return 15. We can have it to 1, it will return 1. But we just want 10. And then we'll do quest.fetchAll. We'll actually update the functions again. For some reason, I keep forgetting to do that. 10 most recent customers, save that, build that. And as you can see, we have 15533133124. If I go in here, refresh that, sort these, use the customer ID. Oops, okay, that was bad on my part. 15533133124. So you can see it gets the customer information from the customers table from the 10 most recent orders. Pretty cool. I'm going to quickly change this to that because I'm kind of curious to see what this looks like. Oh, there you go, yeah. So you have the customer ID, the customer name, the customer phone number, the customer email, then you have the order ID, you have the customer ID again, the product ID, the discount, and the date. So it literally just attaches the order table to the customer table, but it will only do it for a specific column. So in short, it only does it once. Pretty much. You might be able to get away with doing something else, maybe. Like, well, actually, there's only one common factor between the two, isn't there, which is the customer ID. So you need to sign up by the common factor. Hopefully that makes some sense. Again, if you're not understanding this first line, then don't worry about it for now. Go and do some more research in other places, and then come back to this and see if you get it more. But yeah, joins are quite powerful. I'm still not 100% confident with joins, but yeah, and then the second line is a lot easier to understand. So that's all the select statements we're going to do. We've got 15 minutes until the hour. Let's see if we can do the rest of it in that time. So we're going to do some mass updating now. So update discount records. And we're going to have cursor equals cxn dot execute. And then we're going to have update orders set discount equals 0, where So we're basically just resetting the discounts for a specific time period. Maybe something went wrong where you want to retroactively change the records. I don't understand why anyone would do that in production, but I couldn't think of a better example. So I'm going to have a look here and see kind of when was a good time period to kind of show this off, really. So maybe between between March and May inclusive. That could work. Okay. Between March and May inclusive. So between where order date time is less than or equal or greater than or equal to 2018. So 2018 or 2019? It was 2019. Interesting. Yeah. So 2019-03, and I think that will be fine as it is. We'll see. Actually, I'm gonna put 01 in there. And then order date time is less than or equal to 2019, and we're going to close that 05, and then 30 days has September, April, June, and November 31. Okay. You could do like a less than June 1st, but me. Or maybe something cleaner. Let's see if we can make this a bit cleaner. So if you want to do that, we'll see if this works. I actually don't know if like explicit. What the hell? Okay. If just providing a month will work, it should do. In theory, you should be able to work it out. But yeah, we're resetting the discount to 0, where the order date time, or between March and May inclusive. So that should be fine, and we do a cxn.commit just so we can check that it works. And then we're actually going to remember to modify this time. And we're going to update discount records, and we may get an error. No, we don't. Okay, cool. And it's, yeah, okay, so that's, let's see. That appeared to work as intended. Perhaps, I'm not actually sure if these were 0 beforehand. You may need to go with the date, so you can like literally go as finite as you want with that. So just mess around with that. I probably should have done a little bit more checking to make sure that everything was fine. It may have reset these two, I don't know. But yeah, as you can see, it reset a lot. It may have actually reset too much. I really am not sure. Okay, I'm gonna say that you have to have that. We'll leave it like that, because that was working when I was testing it. That worked perfectly. So yeah, just have it like that. So I guess just make sure you specify a date, or do some experimentation and work out if you need to or not. So that's updating. We're now going to do our final thing, so we are going to get there in time, of deleting Z's records. So Z has been a very loyal customer of our business. However, he's decided he doesn't need any more fridges, ovens, and all that jazz, and has decided to delete his account. And we, in the interest of saving data, want to remove all his order records. You probably wouldn't do this in real life, or you might have backup. You might kind of have just a dump of his data, just so you absolutely don't lose it. But because we're going to be deleting his customer ID, we need to delete his order ID as well. So we're going to do cur equals cx_execute once again, and this is going to be a one-liner because it's quite short. Delete from customers where customer name equals, and then z wang. And so if we go back to our script, you'll remember this on delete cascade. So we don't need to do a second statement for orders. This will just work. In the words of Todd Howard. So, and then we can also do a little bit of cool printing. So we can use an F string. We can do cur.rowCount. Now this will tell us the number of rows that were modified in this statement. However, it will only tell us the number of rows that are modified from this table. So it won't tell us how many rows are modified in the orders table. It will just tell us about the customers table. That's kind of a bit annoying, but this is kind of useful. It's kind of useful as a Boolean check more than anything, just to see if something was modified. To say if you did an insert or ignore into, and then you wanted to check if anything was actually inserted, you could use this cur.rowCount. And if it was 1, and then it was inserted, and if it's 0, then it wasn't inserted, and then you can throw up some sort of error saying it already exists. It just prevents you from having to do multiple operations. You can do then records deleted, for example, and finally do the final cxn.commit. It's also worth noting that if you did not do this cxn.execute pragma foreign keys equals on, and you are using an SQLite 3 database model, this will not work. This will execute, but the on cascade or the on delete cascade will not. So that's an important thing to keep in mind. Other database models, again, I don't know. I imagine PostgreSQL does it automatically because it would be kind of dumb if it didn't. I think it's kind of dumb that SQL doesn't, or SQLite doesn't, but maybe they're just trying to line it up a bit. So if you do that, you can see one record's deleted, so our customer record has been deleted. So if we go into here, you can see that Z is no longer a thing. And if you go orders, we'll see that we have 1 to 15 of 41. We had 51 in here, so he had 10 orders clearly. And as you can see, customer ID, there is no mention of the number 5 anywhere. It just doesn't exist. There's no mention of it. So yeah, that is pretty much everything. So these are the functions that we had. Hopefully that is a good enough introduction into SQL. Obviously, if you want to become an SQL master, there is a lot more reading to do. So you need to do some study on different database models. You also need to look more in detail into these data types to work out the differences. However, if you're just using SQLite for now, just get used to it, and you only need to know these 5. And then come back later. You can basically just kind of split them up better. So, for example, you can... I know W3 schools is good for at least telling you what these data types mean, but maybe there is a better resource out there, I'm not sure. I learned through W3 schools anyway. But yeah, if you have any questions about SQL or any of the stuff that I've done in this video, then feel free to leave it in the comments, or you can join the Discord server using the link in the description. While you're down there, I would recommend that you look at my socials. So I have a Twitter, a Facebook, I have a library account, I have all that stuff. I have a new Twitch account actually, so you can go and follow me on Twitch if you want to see me live streams and stuff. Right now I'm currently in the middle of live planning the Twitch IO series, so we're going to be doing an updated Twitch bot. So that should be kind of cool. If you're watching this kind of near when this goes out, if you're watching this a year from now, that's already done. The VODs will still be up if you want to watch those. Or if you want to watch any future streams, I plan to stream more on that. So yeah, that should be cool. But yeah, that's going to do it for this video. If you liked it, then say hello down below. If you really liked it, consider subscribing, hitting the notification bell so you don't miss out on future uploads. And if you really, really liked it, consider supporting me on Patreon. Of course, you don't have to, but really cool thing of you to do. And I will leave you with a final word from the sponsor of this video, Sobrancy. If you're looking to bring a project to life or start a new business venture, Sobrancy is a great way to kick things off. Whether you're looking for a free solution to get yourself up and running or a powerful plan that sets the sky as the limit, they've got your back. With a plethora of features at your disposal, Sobrancy will never leave you asking for more. Don't be afraid to ask for help though, as their 24/7 support line means the answers you need are just a few clicks away. If you're quick on a drawer, you'll be able to get their pay plans for up to 65% off. However, if you're a little late to the party, don't worry, as you can still use the code CARB90 to get 90% off your first month's hosting. To sign up for Sobrancy's fast, affordable and reliable web hosting today, head over to sobrancy.carberra.xyz. See you in the next video.